Resistance. Resistance is the measure of the opposition to current flow, and it is measured in ohms, which is this sign here. An analogy for resistance is it's like a toll booth. If there is only one toll booth open, you are forced to go through that booth, and if there are many booths open, you will most likely go to the toll booth with the shortest line. The more open tolls there are, the faster the cars will go through, and you can only go through one toll. This is like resistance because if there's only one open, then you have to go through that one. And if there are many open, then you're most likely to go to one with the shortest line or the least resistance. And if there's more open, the faster the cars will go through. And you can only go through one path. There are two types of resistance circuits. The first one is a series circuit. And in a series circuit, the charges that flow through the first resistor must flow through the second. And the charges that flow through the second resistor must come from the first. So in order to solve for a series circuit, it would look something like this. You just add up all the resistors to get to the total resistance of the circuit. And what I mean by that is the circuits would look something like this. So the charges would flow out of here, and they would go through all three resistors to make it to the other side of the battery, meaning that the charges that come out of this resistor have to go into this resistor, and the charges that come out of this resistor have to go through that resistor. In order to find the total resistance, you just add up all the resistors. So 50 plus 50 plus 50 is equal to 150. The other type of resistance circuit is a parallel circuit, and in a parallel circuit, the charges that flow through the first resistor cannot flow through the second. The equation is the same as series, except you have to put the resistances under 1, and the circuit will look something like this. So if the charges come out, they can only take one path, so they have to choose right or left, go through resistor, and make it to the other side of the battery. So they could either go through resistor 1 or resistor 2. So the total resistance of this circuit would just be the two numbers, and you put them under 1 like a fraction, and then you get the answer and you put that over 1 as well. So for this particular one, the total resistance would be 25 ohms. And in many of the series circuits, you can combine both series and parallel circuits, and you will get something that looks sort of like this. So in order to solve a circuit like this, you will have to combine resistors in either series or parallel and get combined numbers, and keep doing that until you get a very easy equation to solve for. So you have 8 resistors in this equation, and the first thing I did was I combined resistors 7 and 8 to get 25 because they're in parallel. So 50 and 50 to the negative first, and that answer to the negative first would be 25. And I combined 5 and 6, which you just simply add 100 plus 100 is equal to 200. So the new circuit looks something like this. And then the next step I did was, I kind of did 2 steps in one. And this one, the next one I only did 1. I combined resistor 5 and 6 and 4. And since they're in parallel, you did 100 and 150 to the negative first. Get your answer, put that to the negative first, and I got 85.714. And your new circuit looks something like this. My next step is I added the new resistor we had, 4, 5, 6, and I simply added it to 2 since they were in series. And I got 135.714. Circuit looks something like this. And then you could make it parallel again by getting resistor 3 and resistor 2, 4, 5, 6, putting the parallel 50 to the negative first, 135.714 to the negative first, get your answer, put it over to the negative first, and I got 36.5384. And then now you have a very, very simple series circuit where you could simply just add 100 plus 36.5384 plus 25, and I got 161.538 ohms, which would be the total resistance for this circuit.